Welcome to the deep dive. Today, we're getting into something that might just flip your whole idea of reality.
Yeah, we're talking atoms, specifically just how incredibly empty they are.
Exactly. And what that emptiness actually means for, how we see things, how we interact with the world. If you're up for some aha moments, you're definitely in the right spot.
Absolutely. And we're diving into some great stuff shared by a listener. Let's call them Phil. They sent over this really thought-provoking online discussion.
Right. And it taps into that curiosity a lot of you have about the weirder side of physics.
It does. So our mission today, unpack the key ideas from Phil's source.
We'll look at the sheer scale of the atom spoiler. It's bonkers. Then why we can't actually see the bits inside.
And how solid stuff can even be solid if it's mostly empty space.
Right. And we'll even get a bit philosophical, touch on reality itself, maybe even the meaning of it all. Okay, let's jump in. The scale of the atom. Where do we even start?
Well, the discussion Phil shared uses that classic analogy. Imagine the nucleus is a marble.
Okay, a marble.
And you place that marble right in the center of a massive stadium like the Maracana or something huge.
Right, I've heard this one. So the electrons are whizzing around way up in the stands. That's the usual picture.
That's the common idea, yeah. And it gives you some sense of emptiness. But here's the kicker.
It's wrong
Mm.
or not quite right.
It's not wrong exactly, but it massively, massively undersells the emptiness. Like it's not even close.
Okay, so how empty is it then? If the nucleus is that 1 centimeter marble.
The closest electron wouldn't be in the stands. It wouldn't even be just outside the stadium. It would be roughly 1 kilometer away.
A kilometer. Seriously, from a marble.
Seriously, 1 kilometer, that's the scale we're talking about. The atom is just staggeringly empty space. Our everyday intuition completely fails here.
Wow. Okay. So that stadium visual, while helpful maybe to start, is way off. A kilometer. It's basically just void.
Pretty much. And, to get slightly more technical, the nucleus is down at the femtometer scale. That's 10 to the power of minus 15 meters. Incredibly small.
Okay, femtometer. Got it.
But the whole atom, defined by where the electrons might be, that's more like the nanometer scale. 10 to the minus 9 meters.
So minus 15 to minus 9. That's a million times difference in linear scale.
100,000 times difference yeah. Which means the volume difference is astronomical. Think P in a cathedral.
Right. That was another analogy in the discussion, wasn't it? Nucleus as a P in a huge cathedral.
And the electron is somewhere way out, maybe in the parking lot, miles away, relatively speaking.
That really drives home the emptiness. Okay, so if it's that empty, this leads to the next logical question Phil's source tackled, visibility.
Exactly. Can you even see anything at this scale? If the nucleus is our marble, could you see those electrons a whole kilometer away?
Or even just like what magnification would you need?
Right. So those electrons out there at 1 kilometer visible.
My gut says no, based on the emptiness thing.
Your gut is absolutely right. A hard no. And it's not just the distance, though that's obviously huge.
So what else?
Electrons aren't tiny balls. They're quantum things. More like probability clouds, hazy regions where the electron might be.
Ah, okay, so not a specific point in space, more like a smear.
Sort of, yeah. It doesn't have a definite spot until you measure it. But let's pretend for a second. Let's imagine a tiny solid electron.
Okay, playing devil's advocate.
It has this theoretical size, the classical electron radius is, around 2.8 femtometers. Remember, our marble nucleus is 1 centimeter.
Which we scaled up massively from a femtometer-sized nucleus.
Exactly, by a factor of 10 to the power of 13. So if we scale up the tiny electron by that same huge factor,
It's still going to be minuscule compared to the marble, right?
billions of times smaller than the 1 centimeter marble. So even if it were a solid speck, seeing it from a kilometer away, impossible. Like trying to spot a single molecule with your naked eye from across the city.
Yeah, okay. The discussion compared it to trying to see a thought,
Yep.
right? It's there, but not visually graspable.
Perfect analogy. So electrons are out, invisible. What about the nucleus itself? Our 1 centimeter marble, can we see that from the electron's distance 1 kilometer away?
A centimeter marble from a kilometer? Maybe. Seems borderline.
You'd think so, but it comes down to how our eyes work. Visual angle, resolution limits.
Ah, the physics of seeing.
Right. The discussion did a quick calculation. That 1 centimeter marble at 1 kilometer's distance, it creates a visual angle of about 0.00057 degrees.
Okay. And our eyes limit.
Best case scenario, about 0.016 degrees.
So the marble's angle is way smaller, like 30 times too small.
Exactly. Even the marble nucleus, the solid bit in our analogy, would be completely invisible from the electron's orbital distance.
Wow. So the whole scaled-up atom, this 2-kilometer-wide bubble, is essentially invisible from the inside out and the outside in, at least for its components.
Pretty much, yeah. Just vast, invisible emptiness.
Okay, so that's within one atom. What about neighbor atoms? The discussion used iron, right?
Yeah, solid iron. The atoms aren't just floating randomly, they pack into a crystal structure. For iron, it's called body-centered cubic, or BCC.
Like stacking oranges, but with one extra in the middle of the stack.
Kind of like that, yeah. But even tightly packed like that, there's still heaps of space between the atoms. The average distance between the centers, the nuclei of iron atoms, is about 2.48 angstroms.
Which sounds tiny, but we need to scale it up, like we did with the marble nucleus.
Right. Apply that same massive scale factor, that 2.48 angstrom gap. It blows up to about 2.5 kilometers.
Hold on. 2.5 kilometers between the marble nucleus of one iron atom and the marble nucleus of its nearest neighbor. At this scale.
That's the one. 2.5 kilometers.
That is just staggering. It's not just the atom itself that's empty. Even solid matter is mostly empty space between the atoms.
It really hammers it home, doesn't it? Which brings us right to the big paradox.
If everything is so incredibly empty, why does anything feel solid? Why doesn't my hand just pass straight through this table?
Exactly. Why do we perceive solid objects at all if we scale things up? Like, imagine a single soccer ball 5 kilometers away. You wouldn't see it, right?
No way. Too small, too far.
But the discussion pointed out, what if you took, say, 9 million soccer balls
Okay.
and you arranged them into a solid wall, maybe a kilometer square? Now, from 5 kilometers away, could you see that wall?
Yeah, probably. You wouldn't see individual balls, but the whole surface, the reflected light,
Yeah.
you'd see something. A big white wall or whatever.
Precisely. It's the collective surface area. Now, take those same 9 million balls, shrink them down to marbles,
Oh, nucleus size.
and space them out 2.5 kilometers apart, like the iron nuclei.
Okay. 9 million marbles spread over a vast area.
Would they be visible from 5 kilometers? Not a chance. Utterly invisible. Too much empty space between them.
Ah, so the solidity we feel isn't about the stuff itself being packed tight, but more about the interactions between the stuff across the surface.
You got it. It's an emergent property. What we perceive as solid comes from the forces, primarily electromagnetic forces between electron clouds acting over areas. It's not physical bumping.
It's like why the night sky looks mostly black, even though there are countless stars. The space between them is just too vast.
Exactly the same principle. The universe appears empty for the same reason solid matter isn't truly solid at the atomic level.
So this feels like a turning point. If we can't see the bits, and it's all mostly empty space anyway, is the solid reality we experience just, I don't know, an illusion?
That's the profound question, isn't it? Is our perception just a construct?
Are our brains just making it all up based on limited clues?
Well, in a very real sense, yes. Our brains build models. Light hits our eyes, sound hits our ears, nerves fire. And the brain interprets that into this rich, seemingly solid world.
And touch, too. You mentioned it's not atoms hitting atoms.
Right. When you press your hand on the table, you feel resistance. That's the electron clouds in your hand's atoms repelling the electron clouds in the table's atoms, like magnets pushing apart.
They never actually touch in the classical sense.
Nope, it's field interactions. That repulsion force is what your brain interprets as solid.
Mind blown. Okay, this naturally makes you think about, well, really far out stuff. Like the simulation hypothesis that came up in Phil's discussion. Are we just in a super advanced computer game?
Definitely a fascinating rabbit hole, maybe for another time.
Mm-hmm.
But sticking with quantum weirdness, the discussion also brought up the double slit experiment.
Ah, yes. The cornerstone of quantum mechanics. Because if our solid world is an illusion based on interactions, what happens when we look at the fundamental bits?
Precisely. And the double slit experiment is where things get truly bizarre. It shows particles, like electrons, acting like both waves and particles.
Right. If you don't watch which slit they go through, they act like waves go through both at once, interfere with themselves. You get this wave pattern on the screen behind.
Exactly, like ripples in water. But
Yeah.
the moment you set up a detector to see which slit the electron went through,
Poof. The wave behavior vanishes. It acts like a normal particle, goes through one slit or the other, and the interference pattern disappears.
it's as if the electron knows it's being watched. The very act of observation seems to force it to choose being a particle.
Which is just wild. It makes you question what reality even is when we're not looking. Does the moon exist
Right.
only when observed? That kind of thing.
It raises those deep philosophical questions about observation, consciousness, and their role in shaping reality. The discussion even touched on the delayed choice experiment.
Oh, yeah, where the choice to observe or not is made after the particle should have already passed the slits.
Right, and it seems like that future choice retroactively affects whether the particle behaved like a wave or particle in the past. Time gets very weird at the quantum level.
Seriously mind-bending. Okay,
Um,
so atoms are empty. Reality might be an illusion constructed by our senses. Observation changes things. Where does this leave us with the biggest question of all?
Meaning purpose. Yeah, the discussion went there too. Phil mentioned pondering this, like most of us probably have.
If the universe is this strange, empty, possibly observer-dependent place, what's the point? Is there some inherent meaning?
Or, as the discussion suggested, is meaning something we create, not something we find already baked in.
It used that interesting analogy, Melica, like some forgotten gunk in a lab dish.
Yeah, like goop, basically.
Yeah.
Does that goop have an inherent purpose? Probably not, scientifically speaking. But someone studying it could give it purpose. Or if it were conscious, it could find purpose.
So maybe meaning isn't built into the cosmos, but it's something we assign or choose.
That's the idea explored. If we are in a simulation, maybe the purpose is for the simulators, not us. Or maybe the purpose is for us to figure things out, to grow, to discover within this reality.
Or maybe the inherent randomness, the chaos we see at the quantum level is the point. Like the universe is testing our ability to find meaning despite the chaos.
That's another perspective. It really shifts the focus, doesn't it? Away from searching for a single hidden answer.
And towards the idea that we have the freedom to choose our own purpose.
Mm-hmm.
And maybe that purpose can change over time.
Exactly. It's less about destiny, more about possibility. In a universe this weird and vast, maybe the point is that everything is possible, including forging our own meaning.
It's actually quite empowering, in a strange way.
Hmm.
Instead of a pre-written script, it's a blank page.
Precisely. You get to write your own story.
Wow. Well, this has definitely been a journey into some deep and fascinating territory, and my brain feels a little stretched.
Mine too. But the core takeaway, really echoing Phil's source material, is just how different reality is under the surface. The solid world, far more empty. Our perception, a clever construct.
It really makes you think, if our perception builds this reality for us, what are we not seeing? What aspects of the real are filtered out?
Yeah, and could understanding this fundamental emptiness, this weirdness at the heart of matter, actually unlock new ways to interact with the world, new possibilities?
That is a truly provocative thought to end on, something to definitely keep pondering.
Absolutely. Well, thank you for diving deep with us on this one. We really encourage you to check out the original discussion Phil shared if you want to explore these ideas even further.
Definitely worth it.
Yeah.
Until next time.